All right, in this video, I'm going to go over a little thing that might happen when you're doing U substitution. This first problem is really straightforward. You've done one like this. So I'm just going to kind of go right at this and say, okay, I have something to a power. So I'm going to try to write that as U to the N du so that I can integrate that and get U to the N plus 1 over N plus 1 plus C. So if that's the pattern that I'm trying to recreate, then this would be my U value. So I could say that this U is x squared minus 4, and then du would be 2x dx. And if I go back to my original and I say, okay, this was U, and then du is only x dx, well, my du is 2 times too big. So I have to rewrite the original integral in terms of u's. I have to multiply it by a half. So it would be 1/2 u to the 1/3 du. And let's just make sure everything's there. So u to the 1/3 takes care of this part right here. And then 2x dx takes care of this and this. But since I have the 2, I multiplied by a half. So this is the original function in terms of u's. So then I can go ahead and integrate this, and I get 1/2, and then we're going to add 1 to the exponent. So 1/3 plus 3/3 is 4/3. We're going to divide by the new exponent, plus c. And then if I keep switch flip with the 4/3, I get 3/4. So this would be 3/8 u to the 4/3 plus c. And then if I back substitute, I get 3/8 times x squared minus 4 to the 4/3 plus c. Okay, so that's a nice, easy, very straightforward u substitution. Now, the reason I bring that up is because this is going to happen to you. So all I have to do to change this problem and make it much more difficult is change that x squared to just x. And now I want you to watch what happens. Let's try to do the same exact thing. So let's let u be equal to x minus 4. And then let's let du be, well, the derivative of x, now this is the problem. The derivative of x is just dx. If I try to write this original integral just in terms of u's, watch. I would get the integral of u to the 1/3 du. Okay, but here's the problem. U to the 1/3 takes care of that. The du takes care of the dx. I still have this x left over. You can't just go like that because now you've got x's and u's. You also can't put a variable on the outside of the integration symbol. Okay, so that is not a thing. Never, ever, ever multiply an integral by a variable. You can't do that. The only reason we're allowed to do this is because when I first taught you integration, anti-differentiation, I showed you that you could slide a constant across the integral symbol. You can't do that with a variable. So what in the world do you do if you have a variable left over and it doesn't match your du? Okay, now I'm going to tell you what you can do that will not require you to learn something new. However, I strongly suggest you do not do what I'm about to say because it's going to be confusing. You could switch to integration by parts. I did this one doing integration by parts, and I think it took 2 cycles. You don't want to have to do an integration by parts with 2 cycles if you don't have to. Okay, so I want you to watch for this. When you have just a variable to a power left over, I want you to try this. If you look right here, this little symbol here, the u equals, or not symbol, but like sentence, right? What you can do is, we know what x is in terms of u with some really simple algebra. This, if we solve it for x, because I want to know what x is, right? I don't know what x is. So if I go like this and I just add 4, I would get u plus 4 equals x. And that's actually great news because I have an x here, right, in my original, and now I can write it in terms of u. Okay, so what I'm going to rewrite this integral as is the integral of x, which is actually u plus 4, times u to the 1/3, which is this guy right here, du. So when you do u substitution, your goal is to rewrite the integral in terms of u's and get a form that you know how to integrate. Remember, we only know 3 integral rules. We know u to the n, e to the u, and 1 over u. We don't want to have to make this any harder than it has to be by taking out integration by parts, okay? So when you see this little variable left over, cross your fingers that you can solve your little sentence here for x and then substitute it in. And now you might be like, well, what the heck do I do now? Well, all you do now is simplify this using algebra and then take the antiderivative. So when you have two things being multiplied, there is no product rule in anti-differentiation, so you have to distribute it, okay? And when you distribute, you add exponents. So this is actually the integral of u to the 1/3 times u. You're going to add the exponents, so that would be u to the 4/3, plus u to the 1/3 times 4 is 4u to the 1/3 du. And now we just integrate. So we're going to add 1 to the exponent, which would be 7/3. We're going to divide by the new exponent. Then we're going to add 1 to the exponent again. So 1/3 plus 3/3 is 4/3. So u to the 4/3 divided by 4/3 plus c. And then I'm going to keep switch flip with these denominators. So I get 3/7 u to the 7/3 plus 3/4 times 4 is just 3. U to the 4. It always does that on 4s. And it did it again. 4/3 plus c. And then I'm going to back substitute. So if I go back up here, u is x minus 4. So this would be 3/7 x minus 4 to the 7/3 plus 3 times x minus 4 to the 4/3 plus c. Okay, so that's like a little trick that you really have to know. Okay, you really have to know how to do that. I'm going to write down 2 more for you to do. And what I'd like you to do is pause the video and try them because I'm going to finish the video by doing both of them. But you have to pause the video and try it on your own. So let's go ahead and try the integral of, let's see, 2x times the square root of x plus 3 dx. So let's try that. And then once you're done with that one, try the integral of x over the square root of x plus 2 dx. So give both of those a shot. I'm going to do them right now, but just pause the video and then you can see if you're right. All right, so if you're still playing the video, I'm encouraging you to pause the video and do the problems first. I'm trying to add a new page so I can go ahead and do the problem. But I'm not always going to try u substitution first, but I'm definitely going to try u substitution before I try parts. I would try to see if I could distribute here because that would be the easiest thing. Like if I had something like this, like if I had 2x times x plus 3, just distribute the 2x and go to town, right? Like you don't want to waste time on that one. But for this one, since this is to the 1/2, I can't distribute. So I'm going to rewrite this, and I'll do it below it. So this is really just the antiderivative of 2x times x plus 3 to the 1/2 dx. Okay, so this is another setup of u substitution where we're going to use the integral of u to the n du, and that's u to the n plus, my goodness, u to the n plus 1 over n plus 1 plus c. So if that's the setup, then we want to use the base of the exponent for u. So u equals x plus 3. So du equals dx. Okay, so definitely a problem because if all we have is u du, we've got this guy left over. Okay, so the first thing I'll say is we can take this 2 and put it on the outside. And you might even want to do that before you even start your substitution. It's up to you. But basically, my du is too small. right? So my du is only dx, and I need it to be 2dx. So I have to multiply my integral by 2. So I know that so far I'm going to need 2 times the integral, and this is u to the 1/2, right? So this is u to the 1/2 and then du. Okay, so let's look at it again. I need 2x, x plus 3 to the 1/2 dx. I have u to the 1/2, so that takes care of this. So I'm going to erase some stuff here. Okay, I, by the way, did not move that 2 out there. The 2 that I got is actually because my du is too small, but I'll kind of go through it. Okay, so let's see. U to the 1/2 takes care of x plus 3 to the 1/2. Du takes care of the dx. I need 2x. So I multiplied my integral by 2. So now I've taken care of the 2. I have this x that I need to take care of. So if I go right here, I can solve for x, and I can see that u minus 3 is equal to x. So now I can substitute that in right there, and I can say that if I want to multiply by x, I just have to multiply by u minus 3. So now this, in terms of u, exactly matches my original. And then the next thing you're going to have to do every time you do this is you're going to have to distribute to simplify your expression so that you can anti-differentiate. So u times u to the 1/2 is u to the 3/2 minus 3u to the 1/2 du. Okay, so now we're going to go ahead and integrate. So this is going to be 2 times, and it's 2 times everything, right? Not just the first term. So we're going to add 1 to the exponent and get 5/2, divide by the new exponent, so divide by 5/2, minus 3 times, add 1 to the exponent, get 3/2, and divide by 3/2, and then plus c. So if I clean this up a little bit, because it looks like total garbage, I have 2 times, this would be 2/5 u to the 5/2 minus, now 2/3 times 3 is just 2u to the 3/2 plus c. I'm going to distribute the 2. So 4/5 u to the 5/2 minus 4u to the 3/2 plus c. And then back substitute. So 4/5 x plus 3, not sure what that is, x plus 3 to the 5/2 minus 4 times x plus 3 to the 3/2 plus c.